we have a region, and then we're going to rotate it around these different axes. There's 3 different horizontal lines there. Okay. So here's the curve bounded by this straight line, y equals -1. And the first one, we're going to rotate it. There's the region, okay? We're going to rotate it around the same line, y equals -1. So this is going to create a solid shape. Okay. So we're going to slice it into a bunch of discs, okay? And what we need is the radius of the disk. So the radius of the disk is the value of the function minus the value of the line. Okay, it looks like that. So to get the volume, we're going to add up all those slices. We do that with integration. So it's pi r squared times the width, which is dx. Okay, we're going to go through the algebra here. Now you should do this on your own on paper, just to verify this. Check my work. Okay, there's the integration. And now let's notice that this is symmetrical, so we can go from 0 to 2 and double that. Okay, so there's the 2 pi that's doubled, and we're just going to evaluate it from 0 to 2, which makes it a little bit easier. We just need to put in 2 for x, and again, go through the calculation to check my work. Get common denominator there and simplify it, and you get a final answer. Okay, so that was just the sum of a bunch of disks, right? You're slicing it into disks. So all you need is the radius. Okay. So that's the first one. Next one is a different axis. So same region, same function, same boundary, same region. The axis now is y equals -2. So we're going to rotate it around there, creating another solid shape. All right, but now we're going to slice it into rings. Yeah, that open space. So we need the outer radius. In this case, it'll be the function, value of the function minus the value of the line, -2, and the inner radius, which is just 1. Right, from -1 to -2. Okay, so the volume is going to be pi times the difference of these radii squared, times the width. Okay, so it's the outer radius minus the inner radius, each one squared. Going through the algebra, check my work, please. Okay, the integration really is no big problem, just a power rule. Again, notice that it's symmetrical, so we can evaluate this from 0 to 2 and double that answer. So that gives us 2 pi, that's the doubling, going from 0 to 2. We only need to evaluate it at 2, because at 0, it's 0. And you get that. So go through the calculation and check my work. Okay, so that was a sum of, well, slices that are rings, okay, and summing them up. So you need the outer radius and the inner radius. Okay, if you don't see it immediately, how we get those, just take your time and look at the functions. Okay, so there's the second volume. Okay, one more. There's our region. Let's rotate it. Our axis is y equals 1. So just a different shape. Okay. This will also be, we're going to slice it, and it's also going to be a bunch of rings. So we need the outer radius. That's going to be 2, right? From 1 to -1. The inner radius is 1 minus the value of the function. Okay, so again, we take the outer radius squared minus the inner radius squared times pi times the width. Remember, that's dx, the slice. And here's the algebra. Okay, so watching this algebra is probably not going to do you much good unless you've already worked it out yourself. So you can use this for a check. All right. Again, same story. It's symmetrical, so we can just value it from 0 to 2 and double that answer. So you get 2 pi from 0 to 2. Just plug in 2 for the final answer. The key to these things is to identify the outer radius and the inner radius. Okay. Once you get that, the integrations should be no problem. Okay, there's the final one. So I hope that helped.